So today we are going to discuss about properties of dihydrogen and hydrides. So coming to properties, okay, first is physical properties. So I have written about the physical properties and chemical properties in order to save sometimes, okay. So first of all, it is colorless, odorless, tasteless, combustible gas, okay. So hydrogen, this dihydrogen is a gas, okay, which is colorless, odorless, tasteless, and combustible gas. Combustible means it can burn. It is lighter than air, insoluble in water. So hydrogen is lighter than air, okay, and insoluble in water. It exists in diatomic state H2, okay. So hydrogen, as we have discussed before, so does not exist freely, okay, but it exists in associated form, or we can say in diatomic state, okay, that is H2. Now chemical properties. It is relatively inert, okay. By inert it means it is unreactive, okay, at room temperature. So inert at room temperature due to high H to H bond enthalpy. So this bond is very strong, okay, this bond does not break, okay. So high bond enthalpy means this bond between H hydrogen is very strong, okay. That's why they are inert, or they are stable and does not react easily, okay. Since its orbital is incomplete with 1s1 electronic configuration, so it has 1s1 electronic configuration, it combines with almost all the elements. So it combines almost all with the elements, and it accomplishes reactions, okay, by loss of electron. It can lose one electron, okay, lose one electron to give H plus, okay, or gain one electron to become H minus, or it can share electrons to form a single covalent bond, okay. So it can either lose, it can either gain, or it can share electrons, okay, to form bonds, okay, or to combine with other elements. Next one, under chemical properties, okay, we are going to discuss about chemical reactions of dihydrogen. So chemical reactions. First, reaction with halogens. So halogens, you know, okay, fluorine, chlorine, bromine, iodine, okay, all those are halogens, okay. So group 17 elements. So dihydrogen react with group 17 elements to give hydrogen halides. Let's see an example. So hydrogen halides. So hydrogen and X represent halides. So X can be fluorine, chlorine, bromine, or iodine. Let's see an example. The hydrogen plus fluorine to HCl, the hydrogen plus fluorine to HF, okay, HCl, hydrochloric acid, hydrogen fluoride. Now reaction with dioxygen. So it reacts with dioxygen to give a water molecule. So this takes place in presence of catalyst, or we can use heat also to give water molecule. So the reaction is highly exothermic, that means heat is evolved, okay. Now reaction with dinitrogen. So dihydrogen react with dinitrogen to give ammonia. In presence of molybdenum, okay, catalyst, 2NH3. So this will be 3. So this is also known as Haber's process. This process is used to manufacture ammonia, okay, on a large scale. Now reaction with metals. Okay, so the hydrogen react with metals at high temperature, okay, to give hydrides. Okay, H2 plus 2M to give 2MH. Okay, metal and hydride. So metal hydride. So this M stands for metal. Okay, let's see an example. H2 plus 2Na. So sodium hydride. Okay, it will give sodium hydride. Or let's see another example. H2 plus Ca, calcium hydride. Now the next reaction will be reaction with metal ions and metal oxides. So it reduces some metal ions, okay, in aqueous solution and oxidize metal into corresponding metal. Let's see an example. So metal ions, okay, reduce to metal, okay, from ion to metal. Or metal oxides to metal. Okay, so this is metal ion. This is a general okay, formula. So MXOY, so M represent metal, O represent oxygen, so this is metal oxide. Okay, Y can be anything, okay, any number and any number. Let's see in an example. Dihydrogen plus zinc oxide. Zinc is a metal oxide, so it will reduce to zinc and give water molecule. Similarly, copper oxide, okay, Cu plus H2O. Now the sixth one, reaction with organic compounds. Okay, so first is hydrogenation of vegetables oil. So in this hydrogenation, what happens is vegetable oil is converted to edible fats, okay, margarine or vanaspati ghee. Okay, so this takes place in presence of nickel as catalyst. Let's just say vegetable oil. So vegetable oil, they are usually double bond, okay, unsaturated, means double bond liquid. Dihydrogen, okay, nickel catalyst to give fat, okay, that is solid. So these are edible. Now hydroformylation of olefins. So olefins, they are also double bond, okay. So hydroformylation of olefins will give hydrocarbon, okay. So hydrocarbon, they are single bond, okay, carbon chain. H2 carbon monoxide plus olefin are CH2, so double bond, okay, reduce to single bond, so R CH2 CH2 CHO. It can further undergo, okay, reduction in presence of dihydrogen, okay, to yield alcohol CH2 CH2 CHO to yield alcohol RCH2 CH2 CH2OH. So the presence of this functional group gives OH functional group gives alcohol. Now next topic, hydrides. So hydrides, okay, dihydrogens, okay, combine with almost all elements, okay, except for noble gases to form binary compound. Almost all elements, okay, except noble gases to form binary compounds. Binary means two, okay, called hydrides. Example can be MgH2, okay, CaH2, okay, these are the examples, okay. So if E is the element, okay, we are going to represent the hydride as, if E is the element, then hydride will be hydride is represented as EHX, okay. So this is example of hydrides, okay. Another can be EMHM, okay. So example of this will be B2H6, okay, diboron. Now hydrides are classified into three categories. First is ionic or saline or salt-like hydride. Second is covalent or molecular hydrides. Metallic or non-stoichiometric hydrides. Okay. So first is ionic or saline hydrides. So ionic or saline hydrides, okay. This dihydrogen, okay, react with S block, okay, element, or the first group element, okay. So this S block element, they are highly electropositive, okay, in nature. So ionic hydride, okay, they are crystalline, non-volatile. Non-volatile means they do not evaporate, okay, easily, and non-conducting in solid state, okay. Please remember solid state. So in solid state, they are crystalline, non-volatile, and non-conducting. They are males, okay, males or in liquid state, okay. So when they are in liquid state, okay, they can conduct electricity. Or they can conduct electricity, and on hydrolysis, okay, liberate. This is not hydrolysis, sorry, electrolysis, okay. Electrolysis, liberate dihydrogen, okay. So on electrolysis, they liberate dihydrogen gas at anode. Gas and 2 electron, okay. So these saline hydrides, okay, Saline hydrides react violently with water. Violently with water. Violently means they react effectively with water. Okay, an example is NaH. Okay, plus water to give sodium hydroxide and hydrogen gas, dihydrogen gas. Okay, now second is covalent or molecular hydrides. So dihydrogen forms, okay, molecules with most of the pivot elements. Okay, to give covalent or molecular hydride. Okay, so these hydrides, okay, they are volatile. That means they evaporate easily. Okay, being covalent. And hydrogen, okay, compound, I'm writing initial form, compound of non-metals are considered as covalent hydride. Some example of covalent hydrides are CH4, NH3, okay, H2O, HF, etc. So these are covalent hydrides. Covalent hydrides or molecular hydrides are further classified according to the relative number of electrons and bonds in their Lewis structure. Okay, so according to the number of electrons or bonds, okay, they are classified into three. Okay, electron division, electron precise, and electron rich. Okay, so electron division, by the word electron division, we all know electrons is division means electron is lacking. Okay, so we all know that. So group 13 elements, okay, will form such hydrides. Okay, example is B2H6. Okay, and this element, they act as Lewis acid. Okay, next one is electron precise. Okay, so electron precise means they have the required amount of or number of electrons. Okay, so group 1411, okay, forms this electron precise hydrides. Okay, example is CH4. So usually they are tetrahedral. Next one is electron rich hydrides. Okay, so electron rich means we all know they have excess of electrons. Okay, so they have excess of extra electrons. Okay, so group 15 to 17, okay, from this type of hydride and contain long pairs of electrons. Okay, write in initial form, long pairs. Okay, that means okay, long pairs mean 2 electrons. Okay, so example are NH3, H2O. Okay, so they have long pair of electrons, and since they have long pairs of electrons, they act as Lewis base. Okay, that means they can donate this long pair of electrons. Third one is metallic or non-stoichiometric hydrides. So D and F block, okay, forms metallic or stoichiometric, non-stoichiometric hydrides. Okay, second is of group 7, 8, 9. Okay, do not form such type of hydrides. So this metallic, okay, by the word metallic we can guess, okay, that they conduct, okay, heat and electricity. So only by hearing the word metallic, okay, this comes in our mind also. Okay, so it becomes easy, conduct heat and electricity. Okay, so unlike saline hydride, okay, saline hydride, they have stoichiometry. Okay, so stoichiometry means they have definite composition, okay, or proportions. Okay, unlike saline, okay, mostly non-stoichiometric. Okay, being deficient in hydrogen. Okay, as hydrogen is less. Okay, so they are not stoichiometric. So this is all, okay, for today.